Week 8's content is much nicer if you're using Excel to help you calculate the probabilities, the critical values, and the statistics. Section 10.1 takes a look at what's called the goodness of fit test. For the goodness of fit test, there'll be some type of claim about the distribution, and we're going to take a sample to see if that distribution is really spread out like they claim. For example, I looked up the statistics for a city and found out that of the adults, 45% were single, 36% were married, 3% were separated, 6% were widowed, and 10% were divorced. So I took a sample of a whole bunch of individuals to see if that distribution for the city is actually correct. Now I can find out how many are in my sample if I didn't know by hitting equals sum, open a parentheses, and selecting our sample. There's 200 in this sample. With the chi-squared goodness of fit test, the sample is really my observed values. We need to find out what the expected values would be given my claim is actually true. So to do that, I'm going to say equals 200, and I'm going to multiply it by the percentage in that single category. And so the expected number of singles with 200 should have been 90. Again, if I grab that dot in the bottom corner and drag it down, it'll give me the expected result for each one of those categories. Now we're ready to calculate the chi-squared, which you remember the chi-squared is the observed minus the expected squared divided by the expected value. So I'm going to hit equals, open a parentheses for the numerator, select the observed minus the expected, close the parentheses, squared, we get the caret exponent symbol from Shift 6, and then we'll divide by the expected value, so I'll click that one again and hit enter. Now if I click the cell and grab that bottom right corner and drag down, we get the individual chi-squared values. Of course, chi-squared really comes from the sum, open a parentheses, of all of these values, and so the sum is 9.904. Let's see, that's my chi-squared. We need to compare this to some critical value that will tell us whether or not we can accept or reject this claim or this distribution. Now, I've said down here that the alpha value is 0.05, and Excel can give me critical values quite nicely. If I hit equals chi-sq dot inv for inverse, because we want the value, not the probability, and with our chi-squared test, we will always be doing a right-tailed test, so RT for right tail. Open a parentheses, and we'll put the probability, alpha is 0.05, comma, the degrees of freedom is 1 less than the number of categories I have. We have 5 categories, single, married, separated, widowed, and divorced, so 1 less than that would be 4, and so my critical value is 9.48. Which means the chi-squared would have to be greater than that for me to reject this claim of this distribution. Mine's close, but still smaller at 9.09, so we failed to reject the null hypothesis and say that the claim must be true, at least as far as our data is concerned from our sample. The distribution seems pretty accurate based on our statistical test. Now section 10.2 takes a look at a little bit more complex version of this exact same problem. What I've done here for this sample is I've compared 3 different types of classes: online classes, face-to-face classes, and classes that are a hybrid mix where some is online and some is face-to-face, and compared the number of students that are successful to the number of students that failed. What we want to know is, are these variables independent? Or is there a relationship between whether or not the students are successful and the modality of class that they took? This sample is going to be my observed values. We need to find the expected values for success and failure on each of the variables online, face-to-face, and hybrid. Now the way we do that is first we need to add to our observed a total column. And that's really easy on Excel. In the total column, I'll hit, or in the total row, I'll hit equals sum, open a parentheses, select the values I want to sum, and hit enter. And then I can grab that dot in the bottom corner and drag it down all the way. Same thing for the columns. We need their sums. So equals sum, open a parentheses, select the column, hit tab, grab the dot in the corner and stretch it across. And now we have the totals. Just to keep things clear, I'm going to highlight the totals in this light gray so we don't get them confused with the actual data. Now for our expected outcomes, we need to multiply the row by the column totals and then divide by the total. So I'm going to hit equals. This is first row, first column. So first row, the total was this 93. Select that. Times the column total, first column was 168, select that, divided by the overall total, which is in the bottom right corner, and hit enter. This time it tells me the expected value is 81.8. But I'm going to go into this formula and I'm going to make a minor adjustment to make the rest of the calculations easier. Notice the denominator has D5 in it. I'm going to come up here to my numerator, and every D and every 5, I'm going to put a $ in front of, even in the denominator. So $sign in front of the D, $sign in front of the 5, and then in the denominator, $D, $5, and hit enter. That's not going to change the value that we're working with, but what it does is it locks in the D column and it locks in the 5 row so that when I stretch the formula, that part of the formula will not change. So now I can grab that bottom dot and drag down, and grab that bottom dot and drag over, and it's going to calculate the expected values for every single one of my cells. Now we're ready to find the individual chi-squared values for online, face-to-face, and hybrid, and whether the students are successful or not. The formula is still the same, equals, open a parentheses. For the online success, we'll select the observed, minus the online success expected, close the parentheses, squared, that's shift 6 and then a 2, divided by the expected value again, so we click that expected value again and hit enter. Now we're ready to click that bottom dot, drag it down, drag it over, and now we can find our chi-squared value, which is equal to the sum of all of those individual cells. We have a chi-squared of 6.88. So what is the critical value? The critical value that will tell us if they are independent or if these variables are dependent on one another. Similarly, for the critical value, we'll hit equals chi, SQ for squared, dot inverse, RT for right tail. And the probability here at the top says alpha 0.05, comma, the degrees of freedom. The degrees of freedom is 1 less than the number of rows times 1 less of the number of columns. So we had 3 rows, 1 less than that is 2, times, we had 2 columns, 1 less would be 1, close the parentheses and hit enter, and we find a critical value of 5.99. Our chi-squared went beyond that into the rejection region with 6.88, so we reject the null hypothesis that the variables are independent, and we can conclude that these variables are dependent on one another. It seems success and failure is related to whether or not the course is online, face-to-face, or hybrid. Section 10.3, the calculations on Excel are much simpler, but it is nice to have Excel to calculate the critical values. That's probably the only thing you need Excel for. So here we've got a claim. We're comparing 2 variances. The claim is that the first variance is bigger than the second variance at the alpha 0.05 level. So I took a sample of the first set, 109, found a variance of 38.4. The second group, I took a sample of 87 and their variance was 28.7. When we're comparing two variances, the test we're doing is an F test. So we need to do the F inverse to figure out the critical value. So we will hit equals F.inv for inverse, .rt for right tail. Open a parentheses. The probability is our alpha of 0.05, comma. The degrees of freedom for the numerator is the first sample, so I'll select that one, -1, comma. The degrees of freedom for the denominator is the second sample size, -1. Close the parentheses, and that tells us our critical value for this problem is going to be 1.41. The rest you could probably do without Excel, but just to show how this finishes out, the question is the first variance larger than the second? Since there's no equality there, that claim is actually the alternative hypothesis that variance 1 is larger than variance 2. So the null hypothesis must be the opposite, that variance 1 is less than or equal to variance 2. And the F statistic is really easy to calculate. We just divide the variance from the first sample from the variance from the second sample. So equals the first sample variance divided by the second sample variance, and we get 1.34, which is not past the critical value of 1.41. It's not in the rejection region, so this time we will fail to reject the null hypothesis. We don't have enough evidence to determine that the first variance is in fact larger than the second. These Excel tips are going to make Chapter 10 a lot easier. This is probably the most valuable Excel tips of the entire course because especially with the chi-squared distributions, those hand calculations can become very tedious, and Excel can make it a lot quicker if you set this up for every problem. Good luck on the homework. Let me know if you have any questions, and don't forget, all work this week is due on Friday night. No late work can be accepted. As you work, let me know if you have any questions.